All right, in the second part of our notes for today, we're going to talk about equation writing. And equation writing really is pretty simple also. So what we're really going to focus in here on is a little bit of visualization, which will help us determine which equation we're going to use and then what information we need to finish writing the equation. Basically, it's just two things, either 4p or p. So whichever one you can get from the given, that's all you really need to figure out. Ultimately, we just need 4p. So that's what we're shooting for. So what I'm going to do is plot a vertex, plot a focus, and then that really quickly will help me visualize this parabola has to open down because the focus has to sit inside the parabola. So now I know it's going to be an x-squared equation. So I would go ahead and grab that one. And then we'll just start filling stuff in, right? Well, takes about a matter of 2 seconds because if I got my focus as a coordinate, that also means I've got my focal distance. I know what my p is. My p is -4, so it's as simple as dropping that -4 in and write your equation and you're done. So equation writing can be really super simple too sometimes. Sometimes a little more work up front, but it's again pretty straightforward stuff. Let's try another one. So again, this is all about whatever you're given should help you visualize. So if I've got a directrix at a -1/2, and then I'll do a vertex, then my focus would be 1/2 in the other direction. So now I know my p distance has got to be +1/2. This is also a right opening if I'm visualizing my parabola being drawn here. So now I know I'm using a y-squared equation. And then again, what I'm going to do is grab that information and drop it in. Pretty easy so far. So again, P is the key, right? I'll kind of keep saying that tongue-in-cheek a little bit, but P is the key. Helps you get going, or 4P. So this one says it opens sideways, so plot a vertex going through -2, 3. Now what that means visualization-wise is a left opening, so being a left opening, I know it's a y-squared equation. And then what I'm going to do is solve for 4p because what I don't have is any focal distance. I don't know what the focus is. And what I'm not going to assume, by the way, and this is actually a mistake to do this, is this point would definitely exist for sure because parabolas have symmetry, right? So there's my parabola. But I can't assume this is where my focal diameter is. This is just some random point in the graph, so don't assume that. Go find it. And to go find it, I'm going to take my x and y values and basically just plug them in. So we'll grab those and throw them in there. So now be careful where you're putting stuff, right? So there's my x, there's my y. That'll allow me to solve for 4p. What you don't want to do is don't multiply this together because you really actually want 4p. So 4p being -9/2, then basically I can drop it into my equation and go. If you go ahead and divide by 4 and solve for p, well then you're going to have to turn around and multiply it by 4 to get to be a 4p. So that's kind of a waste of time to do that. So if you can get 4p, that's even better. And there's the equation. Okay, let's try a few more. So given a directrix, again, a visual, so my p distance is 3. This should take us about 2 seconds, right? No shifting going on. It opens up, it's an x-squared. So literally, I know my p is 3. I can drop it in, and I'm done in a couple seconds. So pretty simple, right? Now, this one does have a shift, and also given the directrix, you got to be kind of careful with stuff. I guess the first thing I probably do is make sure I know what my p is, counting carefully. That is 1.5 to directrix, which means my focus actually would sit about right in there if I'm visualizing where it's at. And then the other thing I'd want to know is, what's the vertex with the shift? Well, if you got P and you got your HK vertex and we know which equation we're using, then it's again doesn't matter dropping that stuff in. Okay. What I did here, the 4P, that's just 4 times 1.5. That's where my 6 is coming from. So equation writing you're going to find to be pretty easy too. Shifting or non-shifting, it's all about you getting the 4P going on. Now this one's got a little bit of a twist to it. You're given a coordinate. We do have the vertex sitting there, so that's good. We know it's right opening, so we're talking about using this equation. Again, yes, there's a point right here that I could plot, and that's true for symmetry in a parabola, but we can't assume this is 4p, so you're going to have to go calculate it. But you got a coordinate, so we can operate off of that, and we actually know a lot of stuff here, right? We've got a coordinate for the vertex, h comma k. We've also got just a point that sits on the graph. Of the 5 variables that are in here, y, k, 4p, x, and h, I know 4 of them. So I'll plug in what I know and I'll go solve for what I don't know. So we're going to plug in. So there's everything plugged in. Do a little bit of quick solving. Remember, only go to 4p, don't go to p, because 4p is actually what the equation requires. And then now that I've got 4p and I know my vertex, that's a matter of just dropping that into the equation and you're done. So equation writing, fairly simple. Again, just keep thinking about, what I need, which generally is just 4p, and then in this case shifted, I need h and k, and whatever I don't have, I can always go solve for by using the equation as like kind of a formula. Okay, last thing for us is a word problem. Really, it's a pretty simple idea here. There's just some visual stuff you want to watch out for. So again, our light bulb, the light source is what we're looking at. The question here is, you're given a design of a parabolic reflector and you'd want the bulb to actually match properly the size of the reflector. In other words, the light source has to be at the focus. So it's a design idea. And what I'm going to do is go ahead and just drop in a generic XY axis, kind of help me visualize stuff a little bit. So I'm going to try to put that down there. And then you'll notice over here, I wrote a coordinate 9, 10. Now let me just take that away for a sec before we do that. So things to keep in mind that visually, just to be careful, this is not the focal diameter. It's the distance, basically on the rim, right, edge to edge, but the focal diameter would sit down here and run through the focus. So again, don't just grab this number without paying attention to what it is. But what I can do is go ahead and say if it's 18 all the way across, then that's 9, 10, and plop a coordinate on my curve right there. Okay, well, the question here is about how far from the vertex is the light source. Well, the light source actually is located at the focus. So I'm trying to figure out what P is, but I've got a coordinate. It's an up opening. We'll always assume with word problems that the way the visual is the way the parabola is sitting. So we're going to use an x squared equation. I'm going to drop in my coordinate. And then in this case, I am solving for P because that's what it's asking for. What is the focal distance? And there you go. So again, what I'm really doing is using a coordinate, and then I'm using the equation as like a little mini formula, and I'm solving for what I need. Okay, and that's going to do it for your conic notes for parabolas.